Okay, so we're going to look at intersection of graphed equations and proportional review notes. So we're going to review those proportional graphs and tables and everything that we've been looking at. So an intersection where two lines hit each other. So perpendicular lines. And think about a car intersection. If you've got a four-way stop, they're crossing each other, okay? And your coordinates, your x and y, you go side to side first, right or left. Remember right, when we go to the right on the x-axis, that's positive numbers. If we go to the left, it's negative. Y is our vertical change, so so vertical, up or down. If we go up, that's positive. If we go down, that's our negative numbers. And so if it says find the point that satisfies both equations, it means you're basically just looking for the point that they intersect. So like on the example 1, don't worry about these equations because they've already plotted them for you. We want to see where they cross. And so if we look really closely, there's already a dot there, but they cross at this point. So I want to say that that is my solution. And so I need to figure out the coordinates for that. So right or left first, x or y. So it's at 4 and positive 1. And that's my solution. Okay, so that's where they meet. That's my intersection. So same thing on example 2. I see where they cross. So that coordinate is going to be my answer. And they cross at positive 2, positive 1. On the third one, they cross way down here. And that point is at positive 3, negative 1, 2, 3. So that's it. You're just looking to see where they cross and figure out what that point is. Down here, just a review of constant proportionality, but just looking at some graphs because we still kind of struggle with those. The constant proportionality for the following graphs. So remember, constant proportionality, that's the same thing as slope. Okay, that's your M or K when we're talking about equations. We've been talking about direct variation, which looks like that, but it's the same thing as slope, okay? That represents the same thing. It's the change in y over the change in x. So the constant proportionality on this graph, a lot of times we think we can just count the squares, but not all graphs are going by ones. Okay, in this case, it's talking about the cost over the number of honey packets. So my constant proportionality, my first point is right here. And so let's see what that y value is over that x value. So my y value, it went up 1 square, but where am I at when I go up 1 square? I'm at 16. So my change in y is 16. My change in x is also 1 square, but what is that x value? It's 4. Okay, so 16 divided by 4 is 4. So y equals 4x. So 4 is my constant proportionality. If I wrote it as an equation, it would look like that. So let's look at the next graph. We're comparing, again, cost in dollars. So cost, because that's my y value, over DVDs. So the packs of DVDs. So y is always over x. If it helps you to write the words down, then do that if you can see it easier. So there's already a dot here. And so same thing. If there wasn't a dot, though, you guys know you can make your dots in those crosshairs, wherever there's a cross and the line goes in between it, the crosshairs. So there's a point here. So my change in y went up 1 square, but what's the graph tell you? 10. Over 1 square, but it's actually 3. So 10 divided by 3 is going to be 3.33 over 1. So y equals 3.33x. Okay, so it's saying it's $10 for 3 packs or $3.33 for 1. Okay, let's flip on to the back. Example 6, the graph below represents the number of songs played on a radio station. What is the constant of proportionality? So remember, that's the same thing as y over x. Okay, it's k, m, slope, all the same. Okay, so my y value, number of songs, the x value, number of hours. And so I find that first point. And so my change in y was 15, not 1. So 15 songs in hours in 2 hours. Okay, so I'm just going to divide that. 15 divided by 2 is 7.5. So that's what I'm going to write. I'm going to fill that in for K or for M, same thing. So 7.5x. So the number of songs, I can play 15 songs in 2 hours, or I can play 7.5 songs, 7.5 songs in 1 hour. Example 7, Andrew brought packs of biscuits. Create a graph to determine if the number of packs and price are proportional for each serving size. So we want to see if this table is proportional. And I showed you guys, but just a reminder, this is our x value, this is our y. If we divide y by x on each of these values, if say you don't have 0, 0 or 0 and a y value, then you can divide these numbers to see if it's proportional or not. So take your y, divide by your x, so 8 divided by 1 is 8. 16 divided by 2 is 8. 24 divided by 3 is 8, and 8. So since these are all the same, since I get the same number each time, then it's going to be proportional. Okay? So let's check the next one. 6 divided by 2, and 12 divided by 4, 16 divided by 6. Is that right? No, 16 divided by 6, I'm sorry. And then 24 divided by 8. So, 12 divided by 4. Oh, I'm sorry. So 3, 16 divided by 6 gives me 2.67. 24 divided by 8 gives me 3. Okay, so they were the same except for this one. So we're going to say, since they weren't all the same numbers, we're going to say not proportional. Okay. On this one, I'm going to fill this in with 10, 13, 16, and 19. And so we want to see if I divide my y by my x, do I get the same numbers? So 5 divided by 10 is 0.5. 6 divided by 13 is 0.46. 7 divided by 16, 0.43. 8 divided by 19 is 0.42. So they're close, but since they're not all the same, it's not proportional. Okay, so remember, if they're the same when you divide them, proportional. If they're not, it's not proportional. On your worksheet, the first few problems, you're looking for the point that satisfies both linear equations, or I'm just going to say lines. Okay, so it doesn't say that on your worksheet, but you're looking for the point that, like we did on the front over here. So you're looking for the point that they cross or they intersect. Okay?